Now we'll calculate moment of inertia of a hollow sphere. So this is a hollow sphere which is of mass m and radius r. As being a rigid body, we can see that to calculate its moment of inertia, we need to first consider an element. And as we have earlier discussed, in case of a hollow spherical section, we used to take polar elements like in this situation from the horizontal diametrical line at an angle theta, we consider an elemental ring of width d theta like this. In this situation, this will be a strip in ring shape which is having its strip width rd theta, because the radius of the sphere is r and the angular width is d theta, so the width can be given as rd theta. Now in this situation, if we find out the mass of this element, because on integrating these elements we'll find out the moment of inertia of complete sphere. So we can calculate mass of element as dm is equals to mass per unit area of the sphere multiplied by the area occupied by this strip element. So total mass is m divided by total area of the sphere can be written as 4 pi r square. We'll multiply with the area occupied by this ring. Now the radius of this ring can be taken as r cos theta, because the radius of the sphere is r and the radius of this ring we can directly write as r cos theta. So the length of this strip can be taken as 2 pi r cos theta, which is the circumference of the ring strip, and its width is rd theta. So the area occupied by the strip on the surface of a sphere we can write as 2 pi r cos theta into rd theta. In this situation, this r square pi and 2 will get cancelled out, and we'll be getting the mass of this element as half m cos theta d theta. Now the radius of this elemental ring is r cos theta, so we can write moment of inertia of the element is, as element is ring shaped, its moment of inertia di can be written as dm into r cos theta square. As for a given ring about the given axis of rotation which is passing through its center and perpendicular to the plane, moment of inertia is written as mr square. So for the element, as its mass is dm, radius is r cos theta, its moment of inertia can be taken as dm r cos theta square. Now we substitute the value of this dm here, we'll be getting it as half m cos theta d theta multiplied by r square cos square theta. Now in this situation we can see this di is half m r square cos cube theta d theta. Now this di, so total moment of inertia of the hollow spherical shell can be given as moment of inertia of hollow sphere is, this I can be written as integration of di. We can integrate this expression half mr square cos cube theta d theta, and if we put the limits of integration, we can see we are integrating in terms of theta, so it will be integrated from bottom of a sphere to the top. So angular limits can be written as from minus pi by 2 to plus pi by 2. In this situation, the moment of inertia is written as, here half mr square is a constant which we can take out of the sign of integration. It is integration of cos cube theta d theta from minus pi by 2 to plus pi by 2. Now I'll leave it as an assignment for you to integrate the expression. The final result after a complete calculation you will get will be 2 by 3 mr square, which is the moment of inertia for a hollow sphere which is rotating about an axis of rotation passing through its center. And don't skip the integration, it can be very easily integrated by substitution of t is equals to sine theta. On using this substitution in your notes copy, you can evaluate this and verify this result positively.